bit of a disclaimer. As the data comes in, I may change my position, and I'm always finding something current, and I'm trying to put that into the whole formula of everything. So with that said, the previous videos may have some contradiction to this video, but let's move on. These are drawings I found online. Take note over here. Now, B14, B15, B17 are what we're going to reference now. If we look at here, this is your sheet number, and this is the span that failed. It failed on this at this location over here on this side, this column, this pylon column support. That part's the pylon, right? So it's got a description of roughly 8 foot wide at the canopy, the top part, the failure area, and across the bottom failed also on the bottom deck. That's approximately 31 feet. This is a drain. Don't get that confused with post-tensioning. And I'm going to show you real simple details of this in a moment. Kind of contrary and conflicting things I'm finding. There are two ends of this deck. The future deck. I mean the future bridge, which was approximately 100 foot, and the other, and the one that was built. This appears to be the connection where they'll join them together. Right here is the post-tensioning bar typical. They were going to tie it together with some post-tensioning. The bottoms were only going to be anchored at the deck. This was going to have post-tensioning. I suspect that if the deck flexed, that this would flex with it to some degree. And that was a joint over it. Okay, moving on from there. So that's how you were going to connect the two pieces together. I do not find this the holes for that to be at any location in the images that I discovered. This is the failure, and I don't really see the hole up there where that would post tension through. And I actually see like a bar in the center. But moving on. This is the failure side. You notice that it's 1, 2, 3, 4. These appear to be installed, post-tensioned, pre-tensioned cables. 4 of them. And we have 1, 2, 3, 4. 4 future tubes, if you will. Those tubes correspond to the opposite end of this bridge. So let's go like this. That's the failure side. This is the other side that well, it all failed, but this is the other side of it. If you can see these two, and these two would line up. They're across from each other. Then we have a hole, a pocket, if you will, here and here. It appears that would line up with this guy and this guy. It would appear that way. So this, you know, it's supposed to be a couple more post-tensioning cables run through here to pull the bridge together. And I'll sort of show you the image of that. Perhaps even 2 more, one here and one here with these tubes going the full length of the bridge. I think now we're going to, and so the bridge was temporarily held up with 1, 2, 3, 4. 4 cables. And so we have 1, 2, 3, 1, 2, 3. Perhaps they decide to add 1 here and 1 there. And this guy here, this is the future cable to tie it together. That's the drain. That's the bottom decks. Longitudinal post-tension cable. Sorry, that word tricks me up with myself. That's on the ground. We can't see it here. This is the blister that they tensioned. As we know, if you look at my other video, this was tensioned and failure. But what we're looking for here is, once you show this reinforcement, it's just steel, typical steel rebar reinforcement, the whole across this whole top canopy. The post tensioning went the other way, and that looks like that would be a empty tube, if you will, or it might be one full with a post tensioning cable. This one right here. So let's go ahead and delete that one. So that's out of the formula to talk about. So that tube would be roughly this guy. Could be the empty one. It could have been the loaded one. I'm going with it. It was the empty one. That there's nothing in there. Although you can see online, NTSTB has one where they show the tube and you can see the cable inside of it. So that I'm assuming would be these two guys. What I'm assuming is that there, in this image here, there was no break. So updating my previous video, there was here and here, I said possibly, just a possibility that the both plates popped off under pressure when it was when this was being loaded. It pulled down, it broke it, and then pulled the plates knocked off. With that said, now I'm speculating that no, because I don't see any part of a cable sticking through here lining up with this. So my statement now is no cables were present in these two positions. There's actually four. 1, 2, 3, 4. It apparently based on these guys again. Locations. The drawings call for 3. These drawings maybe they updated when the second or next engineer got hold of it. Here's a location, CC, where the two bridges pull together. There's appears to be 2 post-tension cables holding it together there. This is in line. It could be 2 here, but and at the bottom they're just going to anchor down into the column. And there's your post-tension going across to hold it at the top and give some flex. I'm sure it would strain and move, to what degree they wanted to move. And here's the post-tensioning down the bottom of the bottom deck. Now, with that said, we go to the bottom deck. We can't see the bottom deck besides this image here. So this would appear to be all dead ends. They laid it out, and all the tensioning was done on this end because there's nothing here to access. So it was not intended to have at the bottom any post-tensioning coming across at the bottom. And this image would sort of reflect that. I don't see the bottom of this coming across. So that would imply that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 sections of 6 and 6, 3 there's again. And this possibly reserved open. I don't see it open. It's got a line here. It's not stating anything, but the upper deck, here's your 2 and 2. So this now explains the 2 and 2. So, follow what I'm saying here. So there's the 2 and 2. With that said, there's 2 and 2. Let's line this up this way. This looks like this. So the post-tensioning, this could have been part of the stages that this post-tensioning was not added yet. And then as we see here, you've got post-tensioning here, and they didn't do it oddly. This doesn't break. This design doesn't show it ending near the end. I would sort of want to see this detail showing that this break here, meaning it's going to pick up at the other end. Didn't quite do that. Structure and pylon. So, but I can still go along with that's what their intent was, that this was to be at the end here and here. Because how do you get to it? How do you get to it? Well, if this is if this shape, if you will, it goes too far across. If it was just to go through the deck, that this is just to go through the deck and pull these two at the deck, not actually going all the way through to the other end. That this detail, I'm sorry, it would be down here, where I would see holes. That this little bit of section here would be just this section here, where they would post tension to the top part of this deck, engineered to hold it there, but not all the way through. But that said, we now have these tubes. 1, 2. Those tubes appear to be there's a post tensioning, so that's inside. So that would be this tube over here. And as we look at this image, it would be this tube and this tube. Trying to pull down this image. Oh, I can't. It's the way I loaded it. All right, so let's go on from there. So that tube, loading this back up. So we're looking for the post-tensioning. The blisters are center of the bridge. So if they're center, the load, and these guys are outbound, the post-tensioning is outbound and nothing center, that actually helps the bridge in failure if you start pulling it in tension in the center with number 11. If you start pulling number 11 down, and this is center, center line of the bridge, 8-foot top deck span, roughly canopy. You're at the center of it. I mean, the center is where you can always. Center is usually the weakest point of any structure, and with the canopy being 8 foot wide, the center of that is 4 foot, and this design puts it at 4 foot. So inherently, tensioning number 11 is tensioning the center of the canopy, this archway. Let's get it at a view. Let's get the canopy. So the blisters here. You have the supports out here. These not being installed per the drawing, per the photographs. These installed. So this is open. I've got to put this 1 and 2 as installed, and then an additional one added here, and an additional one here, as you visually see. These oddly, my theory is that this post tensioning should not have been there. That they got everything backwards. That these 2 holes should have been down here. That this blister should have been here. I'm sorry. The post tensioning should have been done down this one, not down this guy. And these holes were actually, in my current theory, in the wrong position. They should be there. That these 2 holes are the post tensioning holes required in the drawing to pull the top deck together, and they would be this guy here. It's center of. They're pretty close, and they're not quite center in the column, but they're significantly. Well, maybe they are in line with there, and visually I'm seeing that camera angle. I could put this one sort of visually behind it because this is shorter than that, but it implies to me that that's opposite. Now these guys, I think, are an upgrade of the bridge plans, and well, we have 6. They're outbound. This could be everything from conduit to, I have no idea, but I think it creates an imbalance also because it creates a pocket. I don't know how far they go down. Maybe it doesn't create much of a pocket at all. Okay, so we've got 6. Now, look at this drawing. This is the, so I got to make sure I don't get confused with the deck along with the canopy. So this is the deck. We don't have to worry about the deck yet because I'm saying the failure happened first at the top and the deck was secondary. And I don't want to, we can find, the deck might have hold the whole support had these all been installed, but they weren't installed. So I don't have to beat myself up too much on that. And I can't get data on this. I don't have the bottom angle of this to show all of that, so I can't go down that rabbit hole, but I can go down this rabbit hole. So these 2 holes are also implying, these 2 holes seem like they would be this guy here in a visual effect, 2 and 2 holes, 2 post tensioning bars lining up with these guys. But remember, this I think might be the deck. 1, 2, 3, 4, 6. So this might be the canopy. Oh, canopy. Oh, good. I'm getting my opposite the way they are doing it. So this is the canopy again. So these 2 guys, these plate, if you will, these 2 holes here are this guys. Remember, I'm doing this video on the fly. I've got some notes to the right, but I ultimately letting the drawings take me recalling what I'm giving you guys. There's a blister center line right here. This little top part. They call it, technically they call it a bar blister, PT, post tension bar anchor blister typical. Okay. This is in the right location. This is stated here, but the drawings can move it around. This is the small section. This might have caused me confusion on the, no. It was the this guy coming down might have caused me confusion coming up. Let's work on this first. Disregard that confusion statement at this time. So we've got the 3 and a 2 longitudinal tendons. 1, 2, 1, 2, 3. This guy's missing. This guy's missing in this drawing. We also don't have the visual of the 2 holes of the post tensioning. It possibly would hold the bridge together when it's in permanent position in that drawing. We have the canopy description here, center line. We have all this clear, wide open. This would be the deck. But in the true, it's cleared wide open in this drawing, and again, it's not clear, and I don't mean clear as in communication. I mean it's not clear literally. It's got two pockets in it which appear to go all the way through based on the other image I showed you, which was this guy with the tubes ready to take a post-tension cabling that they'll pull through. All right, I'm getting close here. We're getting close. Cantilever, we'll move on from that. It's probably the walk around. I don't have to really concern myself with that. Turn around for the platform for the opposite deck. So here's the archway. Radius, I went over that in my other video. You please watch it if you do care. Now we're down to the 3 post-tensioning on the lower deck. This is 16 foot. This is 31 foot. Section CC. Now let's move on. Where is it? This is the post-tensioning. This we'll deal with. This is transverse tendon spacing. They call them transverse tendon spacing. All right, so 29 spaces. I did count this out before. This is our section to fail from here to here, total of approximately 175 feet, as determined by here and here. This does say transverse tendon. Now we look at the this is the different sections. They call them stay 1, stay 2, stay 3, stay 4. We look here. This is the tendon. This is where I made my mistake before, and I'm trying to repeat it to you. This is the deck. This is not the canopy. The deck, though, clearly has stating tendons and the amount of tension required. The stressing sequence for the 4-strand transverse tendon shall be this. So these are not. This is not rebar. This is pre-tensioning transverse going across this way, and that's the longitudinal version of it. And it's going to be 1, 2, 3, 4, and that would be going that way. This guy they're in plane. Now, this is what I have a problem with. When we go to the images, and you can search images, I'm only going to grab a couple of them for you. This is like a lot of rebar, and it's a huge section open. I don't see broken cables. This looks more like, that fiber optic stuff. I see the longitudinal cables, 1 and 2. And I guess we can find other videos to show it there, but you can see the strands, and the strands hanging there bundled. But this, for spacing only being right up here, 2.6 feet apart, I think this is greater in visual, greater than 2 feet apart, 2'6", and yet I only see rebar. This is a rebar, typical rebar ribs. I don't see these guys running across. Now, I've got one more image for that, and that would be this guy. You can see where the layout of the reinforcement rebar, and here's another section of it. In fact, I'd be worried about these guys. When I knew it was post-tension, I said, wow, when they go to take this bridge apart, that's going to be pretty dangerous. They're going to have to use some cutters from a crane, from a piece of equipment, to protect themselves initially when they're breaking all this post-tension sections. And yet, I'm seeing a raft of a rebar reinforcement, not, and these are the NTSB guys, not what it appears to be described as required. Here it is embedded, and here it is embedded there too, and also rather. So was that an upgrade? All right, so an upgrade meaning they decided that this post-tensioning was not required, that this was just too much drama to involve yourself in, that they re-engineered and went the other way with it. Okay, so I think I have one more thing to wrap this up. And here's the canopy. Here's the lower deck. Confirming that, because I have to confirm because I made one mistake in the previous video. Canopy, deck. 1, 2, 3. This, as you can see, this is what I expected to see in another drawing when I said I didn't like that detail previously. moved it away, that this, see how it's open, it's ready for the future, if you will. This would imply this cable would come next. This puts it past the, or this cable would, this is the deck, this is the canopy, this would have given that mid-span support of this 8 foot, 8 foot, and 8 foot, here we go, 8 foot, 8 foot. That one and the other one that was being installed would have given it that strength in the center to make this much more capable right here if they were installed here and here. Of course, it appears they were supposed to be installed once the other end of the bridge was connected. This went all the way through and helped. It held the bridges together. I have a problem with saying that also because the bridge, with what my own statement is, because this gap right here, this dead ends. This guy and this guy appears to be a dead end. This appears to be a clean gap between all of it, and that's caused me conflict with the cabling statements I'm making. But I'm sharing with you guys and showing that the conflicts that we're trying to resolve this and seeing the images. Seeing the real world drafting of it, and right here is where that connection is. The post-tensioning supposedly going all the way through, I believe, in one part of the drawing, calling it the post-tension here to there with a gap. The problem I have with that, you go to post-tension and you can camber this thing wrong with a gap between the bridge. So if you solid shim that, I don't know how they were resolving it. It could break these cables trying to pull it together. This is an odd duck for me. With that, just visually, and wrapping it up again. This is number 11. Oh, wrong. That's not number 11. That's the short version, 98. This is the long version. This is number 11. That's number 10. Opposite number 11, number 10, 2 and 3. This is the one I believe should have gotten the tensioning. The tensioning was on the wrong end. I think again it was never belonged there. They should have never tensioned it. It's just built-in obsolescence to tension it. I think that when they tensioned it, they didn't, maybe in a computer model, they spent 2 hours, maybe they used a computer model that they did not, the model didn't calculate that the other post tensions weren't, the bridge was not fully together, or this was maybe left out in the computer model, the position of these two guys. It's something very simple, the failure of this bridge. Multiple things of simple is what I think is a failure, but I'm ending the video. I hope this gave you more insight. This is the half plan to help people with details. See canopy, half design, the 1, 2, and here's the 3 again. I would love to know more details on this. This leaves it open again, nothing here, so it's conflicting again with the above drawing, because this has it going right down. It has this post tension appears going right down the center and through across into the next section. And here it shows nil. Canopy half section. It's just conflicting drawings. Here again is the opposite side. It's calling it C2, 8 foot canopy. There's a connecting side, I believe. That's a dead end, and that it would be the connection. And here we are down to deck plan with 2. C2, C3. So over here we have the strand, the bundling. It does appear to have C3 mentioned in a absent way. So we'll consider that. Here's C3 mentioned. So perhaps it's just an order of connecting, of tensioning. Well, that's not very important now. I can discount that as being saved here and also being saved. As I said, I do doing this on the fly with you guys. The C3 is mentioned here, so even if it's not mentioned here, it would be like a C also. And you would track down C3 is mentioned here. There it is, lined up right at the corner. With that said, that would be closer to this guy here, here or here. This guy's on the outside and it's near the center line. Don't know. You know, I think this is the cabling. Yeah. This is just to draw it, and this is the structural post cabling. It's obviously much bigger than that. This is just to draw the bridge together, draw it and keep it together on the flex and everything else. And this would be a future post cabling, as it's obviously significantly larger and approximately this shape. So perhaps these guys, I'm ending it now, that these guys were the 1, 2, 3 step. If you 1, 2, 3, 1, 2, 3, and these were just to hold the bridge together. That's how I wanted to end this video with you guys, to show you that that this is this is this. These are smaller holes, 1, 2, and this third lower bottom, no idea. But I don't know where it's coming out through here. Originally, I know I said that, but now this appears to be size and shape that would allow for 1, 2, 3. 1, 2, 3. Center post tension, center post tension. All right, so I'm leaving this open for you guys to speculate, and I'm terminating. Good day, and I hope this is my last video on this subject. Hope they release, because I'm getting comments on the side that are making me do another video, and I got to get to work.